So, another totally brand new thing. We are learning what is called scientific notation.
Ew, it's not science.
Right? It's actually, there's no science in here. But the key word in scientific notation is notation. All we are doing is we are learning a new way of writing really, really big numbers. That's what scientific notation is. Okay? So what I have here, and this is really useful for you, so you do need to make sure you write the chart down, is we are looking at, for scientific notation, powers of 10. So we're starting out here with, let's start in the middle, with 10 to the power of 1. If 10 has a power of 1, what would that value be? 10, right? We're not multiplying 10 by itself at only one time. Okay, so the power of 10 to the first is 1. What about 10 squared? What does that give me? 100. What if I multiply 10 by itself 3 times? Then what do I get? 1,000. So what's happening? Every time that I multiply by 10, we're going this way. Every time that I multiply by 10, I increase by how many zeros? 1, right? The exponents are telling me how many zeros to put. Let's look at it going the other way. If I started at 10 to the third, which is 1,000, and I divide by 10, I'm decreasing my zeros by 1, right? Or I'm moving my decimal place over. Okay? So 10 to the 0 is 1. Any number to the 0 power is always 1. Okay. Now what do you think is going to happen if I start going in the negative direction? The decimal place is going to move. So if I have 10 to the negative 1, what happens there? My decimal is going to move one spot to the left. So my answer is going to be 0.1. What if I divide by 10 another time? 10 to the negative 2. My decimal is going to be 2 places to the left. And what if I have 10 to the negative 3? How many places to the left does it move then? 3. Okay? That's the basis of scientific notation, is that when we multiply by 10, what we're really doing is moving our decimals over, right? Okay, so if we divide by 10, that means our exponent is decreasing by 1. Look, every time I'm dividing by 10 on my chart, my decimal, or my exponent, is decreasing by 1. So my decimal is moving to the left. I go from 1,000. My decimal moves to the left to get me 100. If I divide by 10 again, it moves to the left to give me 10. If I divide by 10 again, I get 1. If I divide by 10 again, I get 0.1. If I divide by 10 again, I get 0.01. Does this make sense? The decimal is moving over. If I'm multiplying, my exponent is increasing by 1. Do you guys see that? Every time I multiply by 10, my decimal or my exponent increases, and my decimal moves in which direction? To the right. This says left. I'm sorry. My decimal moves to the right because my numbers are getting bigger. So first of all, what is scientific notation? Scientific notation is a way to express numbers that are either very large or very small. So if they're very large, that means that they have lots of numbers going on for a really long time, right? If they're very small, what type of number do I have? A decimal, right? So that's going to be very large numbers or something like 5,231,705. That's a very large number, right? Okay, what is a very small number? How about 0.002305889? That's really small, right? So we're going to use scientific notation to represent these numbers in a easier to manage way. Okay? So when we have scientific notation, this is what it is going to look like. We are going to move the decimal places. Oh my gosh. We're going to move the decimal over so that we have a number that is greater than 1. So we're going to move our decimal over so that we have just one number in front of the decimal. And then we're going to tell our reader or whoever's looking at our paper how many times we had to multiply by 10 to move the decimal over that many spaces. So scientific notation looks just like, look at those examples that we all wrote out on the board. Doesn't that look like this? 2.37 times 10. 2.37 times 10 to the second power. That's actually scientific notation. What we're going to do is we're going to take our answers, so the things written in blue, and convert it to the scientific notation. There are steps, okay? So this is considered scientific notation. It looks a lot smaller than writing out a whole bunch of numbers in a line. Okay, so it's always going to be a number, usually it's a decimal, times 10 to some power. Okay? So how do we write a number in scientific notation? Step 1. We want to move the decimal point to the right or left so that we get a number between 1 and 10. Okay? So we're going to move our decimal point either to the right or left, depending on if it's a small number or a big number, to get a number between 1 and 10. Look at 3.1. Is that between 1 and 10? What about 2.37? Is that between 1 and 10? Yeah. So we're going to have a number between 1 and 10 here. Step 2. If the decimal was moved to the left, our exponent will be positive. Which, because we're moving the decimal to the right, correct? If our decimal was moved to the left, our exponent is going to be positive because we're making that number smaller. If the exponent was moved to the right, it's actually a really small number, right? Because it's a decimal. So our exponent will be negative. Okay? So let's do example 1. Your instructions are to write in scientific notation. And here's the number we want to write. 0.000067. Alright, so this number, is it really, really big or really, really small? It's really, really small, right? But we don't want to write 5 zeros in a row. So what are we going to do? Step 1 tells us we need to move the decimal point to the right or left to get a number between 1 and 10. So will I be moving the decimal place to the right or to the left?
To the right.
To the right. So let's count how many places. 1, 2, 3, 4, 5, 6, right? And I stop there. because I want a number between 1 and 10. If I moved it 7 places, I would get 67, and is that between 1 and 10? We're always going to have just one number in front of the decimal place. So what would that be? Let's rewrite it. 6.7 times 10. How many places did I move my decimal? 1, 2, 3, 4, 5, 6 times. But I moved it to the right. So will that be positive 6 or negative 6? Negative 6. Why is it negative 6 and not positive 6? Matthew, do you know why? Yeah, because let's think about it. If I gave you 6.7 times 10 to the negative 6, and I want you to write that in what we call standard notation. This is standard. This is scientific. What would I do to get this in standard notation? Move my decimal how many places? 6 to the left. So let's do it. 1, 2, 3, 4, 5, 6. What do I end up with? Is that what I started with? Yeah. So that's why when we move the decimal to the right in scientific, we have to make the exponent negative. Because we have to be able to go back to what we originally started with. So our answer in scientific notation is 6.7 times 10 to the negative 6. The reason the exponent is negative is because we have to be able to go back to where we started from if we need to. Okay? We are still writing in scientific notation, example 2.